Hey guys, welcome back to another episode of the Mind Muscle Connection podcast. Today I have Alan Flanagan on the podcast. And real quick, I'm going to start doing these intros before just to give you an idea of a speaker that I have, the guest, and then as well as some things that we are discussing. So if you aren't familiar with Alan, he has a doctoral research focus on circadian feeding and chrono-nutrition. He also will be a guest host on the Sigma Nutrition podcast with Danny Lennon, and he's also the owner of Alinea Nutrition. This is basically a education site that looks into his research and other research around nutrition. And he holds a PhD in nutrition from the University of Surrey, where he is currently a postdoc research fellow, and he also completed his master's degree in nutritional medicine. And so in this episode, we discuss some studies he's recently got done around circadian rhythms. So that was super interesting. We talked about jet lag and some things that he does to combat jet lag, circadian rhythm basics, why it matters. We talk about light exposure, energy expenditure, meal timing, what does not matter as much and what does matter, where meal timing does matter, late eating and what is considered late. We talk about chronotype and aging, and when you should care about nutrition, circadian rhythms, and chrono-nutrition a bit more there. So I hope you enjoy this episode. If you haven't yet, give me a follow on Instagram, Jeff, HOEHN_. That's where I'm most active on social media. If you have any questions on this episode, you can reach out to me there. And if you found this podcast be helpful in any way, if you could leave a rating and review, and that will help more people find it. So I hope you guys enjoyed this episode with Alan Flanagan. I'll talk to you soon. Yes, Alan, we had you back on in 2023. It was actually May. Like I was telling you off air, like it doesn't seem like it's been that long. We talk about social jet lag, and that's episode 285 if anyone ever wants to go back. But yeah, man, really appreciate you coming back on here and taking time out of your day. I know you're super busy with all your work you have going on and everything like that. And so I guess since it's been since 2023, about 2.5, almost 3 years now, how's anything big on your end or any big life updates or anything like that?
Yeah, I guess several. So I started in 2024. I started a new grant, working on a new grant as a postdoctoral research fellow.
Cool.
And that grant has been pretty cool so far. So we basically had two studies funded on the grant, and the research that I'm really fortunate to do and run and be a part of with this group is very method rigorous in terms of we have a purpose-built research facility that has sleep labs where we can essentially control everything from temperature to light intensity to when the lights are even on and or not, meals, of course, and the kind of dietary component. So we're able to exercise a lot of isolated control over multiple variables that are relevant to chrono-nutrition and chronobiology. And what's interesting in the chrono-nutrition realm is that most of these laboratory or residential based studies are usually conducted in energy balance. And that makes sense because you want to isolate independent effects of a shift in meal timing that's unconfounded by an energy deficit or weight loss. And so one of our studies, we purposefully wanted to investigate whether negative energy balance influences circadian system timing. And we're just wrapping up dotting I's and crossing T's on a paper that we're hoping to submit in literally, I guess, the next 2 weeks, where we basically found that usually the central clock, your melatonin rhythm, doesn't change at all in response to anything but the light dark cycle. That's just been an accepted characteristic of circadian physiology in humans. But we've actually found that after 6 consecutive days of a 30% energy deficit, there was a phase delay in the timing of melatonin. So that's pretty exciting. And then, so that was the first study on this grant. We ran that November, December 2024. And then just finished up before Christmas, we ran the second study that was costed on the grant, which was slightly different, which was looking at whether the fasting duration from the meal you eat last in the day, dinner, influences your kind of responses to the morning meal, to a breakfast meal. And that bizarrely hasn't really been looked at least in this kind of rigorous context where we know that from a circadian standpoint, like if you eat a meal at 8 a.m., your metabolic responses to that meal are much better than if you ate that same meal at 8 p.m. And we've generally attributed that to circadian rhythms in metabolism that are optimized for the early part of the day. But is it only the time of the day that meal's occurring, or is it the fact that breakfast is the only meal that people tend to eat after an extended period without food? Because if you
Mhm.
have breakfast, then lunch and dinner tend to come in quick temporal succession. So we have run that study now, but we won't have any data on that until our labs come back with the plasma samples all analyzed, probably sometime in April, May. So it's an exciting grant to work on. The first paper, like I said, that we have coming out now, for me personally, is really exciting because it's one of these findings that I guess I didn't quite expect, even though based on animal models, the hypothesis was that we might see a shift, but we're not going to see anything in humans. And we've seen something. So it's always nice to be first author on a paper like that, which is a kind of relatively novel finding so far.
Yeah, no, that is super interesting. So basically, what you said in that first one was the energy. You said 30% energy deficit.
Energy deficit.
You
Yeah.
said it delays the melatonin response. So so what? Go ahead.
So we also had a 5 hour delay in meal timing. And this is where we're not quite sure because we don't have a comparison group without a shift in meal timing. That just would have been insanely expensive to do with our like lab-based studies. So in rodents, if you subject them to energy restriction, their central clock timing can shift with meal times, or it can shift without a shift in meal times. There's a phase change in that melatonin timing. So because we have the 5 hour delay in meal times as well, we actually did the protocol we ran for this study. This our research group, I wasn't part of it yet because I started my PhD in 2019. This study was published in 2017. So this is some of their early work. But basically, for the recent study that I'm talking about, we replicated as much as possible a protocol from this previous study in terms of our participant demographics. And then everything else in terms of the experimental design was identical. The only difference in the previous study, we fed them energy maintenance. And in this study, we had the energy deficit. In that previous study, even with the 5 hour delay in meal timings, we saw no change in melatonin whatsoever before and after the 5 hour delay. So the only difference really materially in terms of the exposure that the participants have undergone is the negative energy balance. But whether, and that's where it gets complicated for the circadian system is a complex system. So the way we're conceiving it is negative energy balance might sensitize the central clock to signals from peripheral clocks that typically are responsive to meal timing. So the question we're left with that we can't answer now is if you just had negative energy balance but no delay in meal timing, would melatonin rhythm still delay? Who knows? That might be something to think about for some future research. But I think the way that we would interpret it now would be that perhaps the delay in meal timing has been a factor in the delay, but that would not have happened without negative energy balance, if that makes sense.
Yeah, yeah. And so I guess for somebody like listening to this, and again, I know maybe I don't know if you're able to maybe go this far with it yet, but what would potentially be like the application that you would tell someone here with that finding
I mean,
potentially?
we don't really know necessarily. We tend to, one of the justifications, certainly in our grant applications for potential application, is in conditions like jet lag. Could something like negative energy balance speed up the process by which there's an adjustment to a new light dark cycle or modify the rate at which melatonin can phase change? That's one possibility, but it's hard to say because this is the problem when you do a study like this and you have a relatively novel finding is we've got nothing to compare it to. So like we can hypothesize till the cows come home and there is some fun in that and some kind of interesting speculation, but like what would the application in the kind of real world be at this point? Ooh, who knows? But jet lag would be something that we might be thinking if this is something that we can replicate would be a potential kind of real world application for it. The problem when it comes to jet lag is we actually have a lot of interesting evidence and like what you can do to speed up adaptations or reduce the burden of jet lag. But no one does it, right? People just get on a flight, they eat whenever they want, they start tucking into shots. They're just like, no one's interested in doing any of these hacks for jet lags. So, yeah.
I've had some clients that have had to fly multiple hours, and like I sit there and write out like a whole protocol, and I go over video, and I'm like, how much of this are you actually gonna do? But I guess probably the main thing with that would be like, hey, what are maybe some of the main things that you can do? Like you said, most people are just gonna get off the plane and do whatever, but I'm sure there's some big rocks that somebody could do, right? Like I would imagine caffeine timing probably would be a big one that somebody can watch or something like that if they're with the jet lag and stuff
Caffeine
like that.
timing and also the meal timing factor appears to be really important because it's something that signals synchrony to the system. I guess it depends on, like, I did a trip to Australia back in 2018 to a friend of mine's wedding. And because I only had 10 days, like, I didn't want to be destroyed with jet lag for a while. I wanted to be able to get after it as soon as I got there and do a lot of things. And so for that flight, I did all of the things. Like 2 days before I started traveling, I was like staying up late in Ireland. I was in Dublin. So I was flying Dublin, Dubai, Sydney, then direct. And I stayed up late a couple of nights. So starting to like delay myself a little bit. And Sydney's difficult because you're actually advancing, you're going east. So the main goal with that staying up late, especially the night before I traveled, was I wanted to be actually quite tired. I wanted to be really fatigued. And the reason for that was once I started, this is usually quite helpful, especially if it's a big kind of over, say, 5, 6 hour trip, is if you start getting your clocks on the time zone that you're going to, this really helps you start to think about what behaviors you want to do and when. So I knew that, for example, the timing of the Dublin flight to Dubai was at 11 o'clock Dublin time, but that was basically evening time Sydney. So I stayed up till whatever it was, like 3 in the morning, just doing stuff and only got like 3, 4 hours sleep before I got up and had to go to the airport. I was exhausted in the airport. So it meant that like when I got on the flight, I'm already in my head, I'm like, I'm on Sydney time and it's nighttime in Sydney. It's 10 p.m. in Sydney. So I took a melatonin and a sleeping tablet and put on like a blackout eye mask and just went straight to sleep and slept for most of the 8 hours it was to Dubai. And that's a decent chunk, right? Because it's relatively like an 8 hour kind of sleep opportunity. So then as soon as I'm in Dubai, then it's caffeine timing and I'm really like hitting because my goal then is to stay up and not sleep on the next leg of the flight to Sydney so that when I get there and it is actually 10 p.m. when I get to Sydney, I'm now also tired because I've forced myself to stay awake. So I used the second flight to crush out loads of I was doing my master's dissertation at the time. So I was like, I'm in this for 14 hours and I just kept going down to the galley and getting more coffee from the air hostess. And all of that, a big part of that then was my meal timing. So the day before I was going, I was as much as possible not eating just randomly or on Irish time. And then I follow that through for the day of travel. And it made a subjectively a big difference overall because although I was tired in the morning when I was waking up in Sydney, as you would expect, I was still able to wake up at about 8 a.m., feel a bit tired and groggy, but as soon as I'd had an espresso, I'm fine. So that's a really extreme example, but they're typically the things I would tell someone to do is, I guess the top line ones would be think about the time zone that you're going to. What time is it there? Is it a time you would eat at if you were there? If it's 2 a.m., you're in your new time and you're in where you are about to travel, then don't eat and then start to switch onto eating in conjunction with your new time zone as much as you can. And then trying to time your sleep as much as possible according to where you're going, if that's possible. That's not always the possible one. So I do think that then things like the meal timing and timing of things like caffeine and other behaviors to the time zone that you're going to, at least thinking about that a day in advance. Unless it's extreme, like Australia, most flights are, if you're going something that's 8 hours or less, like a day before, starting to think about what that's going to look like when you get there and adapting behaviors accordingly, I always think. And then the day of travel itself, I think, is usually sufficient.
I've never had to travel that far, so I've never really had to. I've flown just, I think the furthest was like from to the Pacific time zone, so 2 hours behind me, maybe 2 hours ahead. So I haven't really done anything extensive. What would, I guess, is it just you just feel tired and then what, you're like up in the middle of the night? Is that kind of how people experience that kind of jet lag? Is that usually how it shows up
Yeah,
for a lot of people?
mostly. I think when people go west, it's always easier because it's just like staying up late.
Yep.
And the way our circadian system works, that's always easier. What's difficult is going like east. So going from LA to New York, or New York to London, or London to Hong Kong or Sydney. That's always the challenging one. And yeah, like generally when so I grew up in Hong Kong, so I spent my entire childhood, adolescence into my kind of early 30s because my parents were living there doing these trips like London, Dublin, London, Hong Kong. And I never knew any of this stuff. So I would just eat whenever, like when I was older, I would have some drinks on the plane. And I would just be completely fucked for 3, 4 days when I got to Hong Kong. Like I wouldn't be able to, yeah, I would have to like, I would feel like I have to go to bed, but I would sleep. Certainly, if I landed in the morning, I would like sleep till 2, but then I'd wake up at 2 p.m. Hong Kong time, but I'd also be exhausted. And it would really take several days to start to feel somewhat normal. So it's just the farther you go, especially if you're going east, the more your internal clock is messed up and it can take a while to adjust. But going west is always easier and shorter distances are always easier and they're slightly easier then to play around. If people are like regular flyers and they're like in the States, for example, just work requires them to cross the country regularly, like a lot of this stuff can help. And my dad was a commercial pilot, for example. So when myself and my brother were young, and he would do long haul trips like Hong Kong, London, or Hong Kong, Dusseldorf, or somewhere like that, he never wanted to be jet lagged coming back because having a 6-year-old and a 4-year-old is like chaos if you're jet lagged, right? It'd be hell. So when he did those trips and he might have a couple of days layover before flying back to Hong Kong, he would always stay on Hong Kong time wherever he was in Europe. So he would just like sleep during the day, black out the room, be in the hotel gym at 3 a.m. if that's if that corresponded to like the afternoon Hong Kong time, stuff like that. So you can do these kind of things where you manipulate the factors that we know influence the system to ease the burden of jet lag. And personally, I think it can be really helpful.
I'd be curious to hear your thoughts on this. If somebody, let's say somebody doesn't take care of these things and they travel east, their circadian rhythm's all out of whack, they're tired. Is that going to impact like blood sugar stability, things like that too? Because I know that if there's some dysregulation there, I know that system can be off a
Yeah.
little bit. Would that be something that would potentially
Yeah.
happen just with jet lag too? Or
So yes, it would, because again, the system is now everything about the circadian system it's a prediction system. It's an anticipation system. Like you wake up at a certain time in the morning because your body's anticipating that it's the early part of the day. And the same goes for meal timing. Like the reason why, eating a big meal at midnight is so handled poorly metabolically and leads to impaired glucose tolerance and a relative degree of insulin resistance and extended postprandial kind of fat circulation, all of these kind of things is precisely because internally the body is now not anticipating that any big meal is going to be coming in because its timing is calibrated for where you are is midnight. So if you go somewhere, you're traveling to a new time zone where it's 8 a.m. there, but you've just arrived and your body clock is still thinking it's 1 a.m. and you go to have breakfast, your metabolic response is just immediately congruent with the clock time in the new time zone you're eating in because internally it's still calibrated for the place you left. So you would have impaired glucose tolerance. There is research on this kind of stuff. There's a degree of impaired cognition as well, obviously, because if you're just the effect of sleep curtailment or sleep deprivation or poor quality sleep, all of these factors can be something. It depends on what people have to do. If people are going on a holiday, sometimes they're like, I don't really care if I'm a bit jet lagged, if I'm just going to be sleeping on a deck chair in the sun. Yeah, it really just depends. If it's work related and someone needed to have their brain intact or they're thinking about kind of long-term health and they do travel regularly, then yeah, I think these things are like definitely worth considering.
even the person that is just going on the trip, I agree. I think it's like, hey, if you just want to, whatever. But I think you could even just feeling better for that. And if you are someone that is health, body comp focused, that I'm sure it's not going to make a massive difference. But again, trying to get that in line as quick as you can, you're going to feel better. And again, from a body comp perspective, I'm sure that's going to be better there. But I'm assuming too that like even your metabolic health, like going into it, probably is going to play a huge role in it as well. Like someone that is exercising regularly, they overall have good metabolic health, it's probably not going to be as detrimental to them as it would be.
No, you wouldn't expect eating out of whack would not be as detrimental to someone that's already in good metabolic condition. And really isolated traveling once or twice a year is not going to be something that like massively adds up over time. This kind of is more of a something that would be for people that maybe work in aviation or are required to travel regularly for work. And again, it doesn't always have to be like a lot of major little, like a good example, like if I'm, so my brother lives in Chicago, so I'm usually over there at least once a year. When I'm coming back to London, I'm now doing this, I'm going east and it's about a six hour time difference. The most I'll do is it's the day that I travel or the day before, let's say I'm getting an evening flight, Chicago time. I'll usually have my last meal in Chicago sometime around 2 p.m. So I basically have lunch, breakfast and lunch as normal. But then because that 2 p.m., I'm now thinking London time. So that's 6, 7, 8 p.m. in London. That would be my usual dinner time. So I don't eat. So I fast through and I sleep on the flight because it goes overnight until I land back in London. And then I just start having my breakfast as normal. And again, it definitely, there's little subtle differences that I can notice if I sleep on the flight rather than just stay awake watching movies. And if I do that kind of extended fast, then like I have a bit of a more rapid adaptation than if I just ate as I pleased, ate through the flight, stayed up most of the flight watching movies. Like I would just be fucked. Like when I arrived the next day,
Getting
and a
the
lot
free
of that
coffee.
would just be yeah, yeah, and a lot of that would just be like sleep curtailment itself having a negative impact. So yeah, it depends on where you're going, what you want to do, how you want to function when you get there, and then you can cherry pick how many things you want to start modifying or thinking about in advance.
While we're on the topic of circadian rhythm, and again, I know this is your line of focus and you love circadian rhythm. I know chrono-nutrition is right up your alley as well too. With circadian rhythm stuff, I feel since you're more involved in like really involved in it, do you feel like the interest in it has picked up recently in the last couple of years and you feel like it's getting more attention, or do you feel like it's the same? And again, maybe if you're in it, it's hard to know for sure, but yeah.
I think it picked up about maybe a little under 10 years ago. I think it really, I guess I started noticing a pickup much more in say 2017, 18. That's certainly when the chrono-nutrition research area seemed to really explode. And I guess that explosion during my master's was very much a factor in. I was like, oh, this is a relatively new and exciting research area where it seems like there's some stuff to uncover as opposed to other areas of nutrition research, maybe more metabolism rated or diabetes or something like that, where there's a pretty substantial body of evidence. So that was certainly what attracted me to it at the time. And then I think you had some kind of populars like you, that guy, Matthew Walker, wrote this book,
Yep.
Why We Sleep, and that was like hugely popular. And so that enters into the popular consciousness. And then I guess in recent years, yeah, you've seen like more of a prevalence of people wearing like blue light blocking glasses and this kind of stuff in the biohacking realm. So I think there's been different levels of increase interest and discussion, some in the research world, some in the kind of popular realm. But yeah, it's just something that I think people are generally interested in because it is interesting, right? Like it's a lot of it is everyone's experienced jet lag at some point to varying degrees of extremity, and everyone's definitely pulled an all-nighter at some point, whether it was a college or a wedding or a party. So everyone knows what you're talking about in that sense, right? It's something that everyone has a degree of, oh yeah, like I know what it feels like to be really tired, or I know what it feels like to fly to a new time zone and eat and wonder, Jesus, why do I feel really bloated or something like that? Because it's like your stomach still thinks it's 3 a.m. So everyone has these little experiences that I think allows them to be like, oh, this is what's going on under the hood. This is really interesting. So it retains this kind of popular interest, I think, because it's a kind of interesting domain of health and human physiology.
And maybe, and you might have hit on this a little bit, but I want to start with kind of an overview of just circadian rhythm in general. And then I do want to go into the chrononutrition there with that. But I guess what is the importance of circadian rhythm for someone who maybe they're hearing us talk about this, they've been hearing it now, and they're like, okay, why the hell does this matter to me? And again, maybe this person's body comp focused, general health. Is there any I guess how would you explain to them why it's important to understand their circadian rhythm, and do they need to know?
Yeah, because it knows about you, whether we like it or not. It's a really interesting aspect of human physiology. Basically, we have this system that, and the reason it's important from a kind of health standpoint is it exists in every cell and tissue and organ system in the body. Like every cell in your body, almost every single cell has a clock, literally has an as a timing mechanism in that cell. And historically, we would have evolved not spending so much time in indoor buildings. And we have evolved a system that is very sensitive and relies on signals from the environment. So if I took you and stuck you in a pitch black cave and just left you there for a few days, all of your circadian rhythm would still run. They would still have a kind of a rhythm to them, but they would become desynchronized from the 24-hour day, from the time of 24-hour time period. They would most of them would run longer than that. So what happens when we're exposed to daytime light exposure or the light dark cycle, and then other factors like our physical activity and our energy intake and social timing and stuff like that, is that those internal biological processes synchronize exquisitely to precisely 24 hours. And that's why they're called circadian. It's derived from a Latin word meaning around the day. So the rhythm length is 24 hours once it's synchronized, which of course is the Earth's rotation every day. So we have this really intimate link between these clocks in our brain, in our pancreas, in our gastrointestinal system. And the analogy that I typically use for people to gather it is it's the same kind of relationship between an orchestra and a conductor. So the conductor of this system is in the brain, and the remainder of all of these clocks in different tissues is the orchestra. Now, the within an orchestra, right, different components of that orchestra are playing independently. Like the violins are playing slightly separately from the oboe and this kind of thing. So the clocks in the body have the ability to do that. Like the clocks in the gastrointestinal system have their own timing that's independent of the conductor in the brain. But the system from a health standpoint works best when all of the timing of the component parts of the orchestra are following the conductor and are all playing in synchrony. But when they're not, then it sounds like shit, basically. The orchestra sounds terrible because the violins are playing on their own and it sounds awful and everything else. So that's always the best analogy I use. And the challenge with this is the effects can be subtle outside of extreme dysregulation. So, for example, we know that long-term night shift work really messes people up health-wise long term, even if they try and do all of the things to offset that. Their risk of cardiovascular disease, metabolic disease, cardiovascular disease in particular, it's through the roof. And that's the result of long-term dysregulation of the system, just constantly spending time with the orchestra playing out of tune and never having the opportunity for it to synchronize together because you're constantly going from one state of dysregulation to the other. What we're more interested in now in the field is, granted, we know what extreme dysregulation does long term, such as night shift work or just shift work generally. What are the effects of less extreme but more chronic disruptions to the system? So we discussed social jet lag on the last episode. That's an example of that. What's the long-term impact of that? And we don't really have very good answers to it yet. If someone is thinking about this purely more from a performance and body composition standpoint, for composition, it might be something that if someone was in more a constant state of relative kind of dysregulation, it's likely that it would be more difficult to lose fat. You would still lose fat if you've got the requisite energy deficit, but it might be a slightly longer slog in order to do that versus someone who had like really consistent sleep-wake timing and all of that kind of stuff. That's plausible. The second thing is for people who aren't just concerned with body comp, but are concerned with performance. That's probably something where it would show up a bit more. There's some really interesting research on Timing of like maximal strength and power output seems to follow some degree of circadian rhythm. So, yeah, there's probably a rationale for people to think about this stuff without sweating all the small stuff. And a lot of it for me comes back to like relatively simple, kind of practical advice in terms of being relatively consistent with sleep wake timing and relatively consistent with trying to get some decent outdoor light exposure during the day, especially during the early part of the day, if possible. Again, different parts of the world make that slightly different in terms of the ability to do being relatively consistent with meal timing, not always eating very late. Like some of these things are just simple. And again, they may not necessarily be immediately noticeable, but these are things, this is the difference between thinking about a kind of short term, more performance body composition goal. What does my health look like in 40 years' time? And that can be a hard sell for people.
I like you that you brought up though. We know obviously in extreme examples like shift work and stuff like that, there's going to be that dysregulated circadian rhythm. But like you said, the more everyday, I guess, smaller changes, right? Someone that does work, like we talked about social jet lag being something there. What would you say are some of those things that, again, you don't do shift work, but are there common things that you see people do? I know you said some things that we can do to help, but are there common things that people do in today's modern environment that make them less that sort of have that small kind of dysregulation that I'm sure adds up over time there? Is there anything specific there?
Yeah, the biggest one would be lack of light exposure, especially in parts of the world, especially at this time of year, like we're recording in January. Parts of the world can be dark late in the morning and get dark early in the evening, and that often coincides with cold or unpleasant weather. So the reason that's important is because natural outdoor light exposure is of a far greater intensity than indoor light exposure, even if indoor light exposure feels quite high intensity. In our lab, we set light exposure to a measure of light intensity known as lux, and it's about 500 lux. When it's actually 500 lux, it's the kind of light intensity that could give you a headache. But 500 lux outdoors is nothing.
Right.
Like the light intensity, especially on even on a cloudy day, but if it's a bright day, blue skies, your lux is in the thousands. That the consequence of that is interesting because what it typically happens is if people don't get enough adequate outdoor light exposure or light intensity, then they tend to become later chronotypes. They tend to their natural pattern drifts later. So they end up going to bed later, they're getting up earlier. Whereas when people have more an appropriate kind of external light exposure, that tends to come forward. So as part of, especially for people that like don't really sleep well, as part of improving your overall sleep architecture, most people just think about the sleep itself and okay, like going to bed, I won't doom scroll Instagram and these kind of things. And they're good, right? They're useful to not be stressed when you're getting into bed or not have too many things swirling around the back of your mind. And like all those things for better sleep are good. But the one thing people probably aren't aware of is just how important and how useful appropriate external light exposure can be for helping to regulate your overall sleep architecture and sleep quality. So yeah, I think that's a really underrated hack, so to speak, in terms of improving sleep quality.
Yeah, so getting that bright light, like you said earlier in the
Yeah.
day, I think I saw something recently in terms of ideally if you can get it before, like I know the time's gonna be different for each person in terms of when they wake up and and whatnot, but I think before 10 a.m. if you can get outside and get that, like that's going to be a little bit better to help move your circadian rhythm forward a little bit.
It would depend really on someone's natural kind of chronotype and their body clock. But yeah, if you're the kind of person that wakes at 7, then yeah, getting that before 10 could be great. If you're the kind of person that wakes, and there are these people who wake naturally more at 9 than like before midday or something like that. It's really within, generally, we would say, and when we give advice to our participants, because we want them to be consistent with outdoor light exposure before they come into the lab, we typically ask them to do at least 15 minutes within the first 90 minutes to 2 hours of waking. If that's just something like walking the dog or whatever, then that's okay. A lot of people, depending, like will end up getting something like that because they have a commute for work or they might cycle to work or something like that, which is great. But for people that don't and who might like work from home, there honestly is this capacity for people to just end up waking up, not leaving the house, starting work, and then they haven't been outside all day. So yeah, in that context, it can be worth more purposefully looking to get that kind of 15 minutes ish within the first 90 minutes of 2 hours of waking whenever you happen to wake.
So getting it as early as you can. If you can't, is just getting outside at any point in the day going to
Yeah.
be better than nothing?
Yes. Yeah,
Okay.
absolutely.
And then what about on the back end? Do we need to worry about light exposure at night too? I'm assuming that can impact melatonin on the flip side, right?
Yeah, it does. It can have a suppressing effect on melatonin timing and the magnitude of that. And because light is such a signal to the system, then generally, yes, like avoiding like a lot of devices now, like laptops and stuff, there are some pretty good softwares, or even a lot of more recent models of devices are often built with like different backlight settings into them and stuff like that. Like I use a software called Flux, which is free to download, and like you just set it to your time zone and it will like naturally dim. You can actually see it happen if you're like on the laptop where your screen looks like it goes orange. You get used to it really quickly, but you can see this kind of because it takes the kind of bright, high intensity, like in terms of spectral intensity, it's called blue light, out of the screen. But just generally, yeah, like soft like side lighting in the evening and stuff like that can all be relatively helpful. Proximity, obviously, to the retina, to the eyes is also a kind of factor. So, generally like getting into bed and then having the phone like 6 inches from the face on a bright setting is not ideal. Those factors definitely can help in terms of sleep quality for people that are sensitive.
You brought up the light and the kind of more that orangish light. You can turn the night light on. I'll tell you what, when you do that and then you switch back to like normal, you can really tell a difference. I think it's like a little
Oh
bit more
yeah.
subtle if you're not like you're used to it, but then you go back and it's like, damn, okay, that really does make a big freaking difference there.
Yeah. Yeah. If you switch from something that's like dim to bright, especially in the evening, it can be really jarring.
So are you what I know you brought up blue light blocking glasses earlier. Is that something that you would think would be helpful, or are you mostly okay, let's maybe focus on yeah.
No, yeah, I don't think they're entirely necessary. We used them in some of our studies before. I don't think they're entirely necessary for people in their day-to-day life. I see people wearing them outside, and I'm like, in, I don't know what they're doing. But I generally think just being mindful of your light environment at home in the evening is sufficient. And yeah, like having something that can dim the light out of your screen, for example. Like we have a lux monitor, so you can test light exposure. So when our participants, for example, are in our studies, we'll get them to like take down the light in their screen, and you can get it so that you can hold a lux monitor right up to a laptop, like 2 inches from the screen, and it's still like less than 10 lux. So that's completely fine. So it's not you don't necessarily have to wear the glasses. You can create the same effect by just modifying the brightness and intensity and like maybe having an additional some like a software like Flux, or not having like your house lit up like a Christmas tree in the evening and having side lighting and stuff like that. And all of that I think is sufficient for most people.
Yeah, we don't you don't need to be neurotic about it, but there's some low hanging
Yeah.
fruit things that you can do that will make a big difference. I think we already established like, getting outside is going to be the biggest thing, right? You don't need to nitpick some of these things at night, but definitely getting outside as early as you can in the day is going to be big there.
Yeah.
What about bright light therapy? Is that something that you would recommend for someone if they can't get outside, or yeah, what do you think of that?
Yeah, I haven't looked at the research in years, and I did have I need to follow up with one of the chronobiologists in our research group had said something like the initial enthusiasm for some of the research in that area, which was really positive, may not quite have been as optimistic as we thought. But I don't know. I'll follow up on that question. I do know that generally there was a sense that for people that can't, if you lived in Norway and you're somewhere or Canada, like you're somewhere north enough that you're gonna have a really, especially this time of year, very narrow window of opportunity for daytime. Then something like a bright blue or white light could, in that circumstance, certainly be useful. And that's where I remember the evidence standing that it could like have, for example, like a mood boosting effect and generally have a kind of positive impact on subjective sense of like energy in certainly in a cognitive sense. But yeah, it's been a while since I've looked at that. I'd be interested to know where the research stands now, because those statements are definitely probably about 4 or 5 years old.
Yeah, and yeah, got to stay up to date on, because who knows? Like you said, 4 to 5 years. I feel like a lot. I know research can be slow, but it can also change. I feel in 4 to 5 years too.
Yeah.
So it sounds like, again, you don't know for sure. The old research says probably for some people probably effective, and especially in like super niche cases. But obviously want to get up to date on that. What about total daily energy expenditure and circadian rhythm? If that's something that is off for someone and they have some dysregulation there, can we see differences in total daily energy expenditure, or do you think that in itself wouldn't necessarily explain differences
No,
in?
no, we've looked at this pretty in depth in a couple of papers, and even like thermic effective feeding, because that was a big one people were suggesting from a couple of studies that kind of found, or at least suggested that they had shown that your thermic response to breakfast was like 2.5 times greater than than dinner, than a meal at dinner, even if it was the same energy content. And that had everyone being like, oh, this might explain why high morning energy intakes lead to greater weight loss, because you're just simply, but your energy expenditure is higher. So we've looked at this pretty robustly now during my PhD. It was my PhD grant and the research that was part of my PhD that kind of settle this, I think. The first is that we don't see any difference in total daily energy expenditure, even if we like delayed meals by 5 hours or those kinds of interventions. Total daily energy expenditure doesn't change. And that includes even if you don't just delay meals, but also delay people's like sleep wake cycle by 5 hours. So total daily energy expenditure doesn't change. But what research was showing was that, like I said, there was several of these studies suggesting that your energy expenditure response to a meal, if not total daily energy expenditure, but your expenditure response to individual meals was significantly greater in response to breakfast than, say, a lunch or dinner. And we published a paper in the Journal of Clinical Endocrinology and Metabolism a few years ago where we basically showed that this is not those studies were basically showing what amounted to a kind of a mathematical error, a measurement error, because what they were doing was if you're calculating energy expenditure after a meal, you need something to calculate it over and above. And often what people would do with some of these studies is they would use the resting metabolic rate measurement taken immediately before that meal. The problem is, going back to that comment about breakfast earlier, the only meal you eat in a true fasted state, so the only RMR measurement that is a true fasted baseline is the one before breakfast. After that, then you have a 500 calorie meal at breakfast, say, or 700 calorie meal. By the time you get to lunch, you've got carryover effects of the energy intake from that meal. So that's one thing. But then there was also research done by a group in Harvard that showed that resting metabolic rate is a circadian rhythm itself, meaning that across the 24-hour day, resting metabolic rate varies. The variation between the lowest point and the highest point is about 130 calories, which is quite substantial if you're actually interested in how much energy you burn after a meal, which is typically in a much smaller magnitude. And we had a really brilliant postdoctoral researcher, Dr. Leonie Ruddick Collins, on that project that I was doing my PhD. And she developed a model that allowed, using this data from this group at Harvard, that allowed us to statistically adjust for the underlying value of the circadian RMR. So we could take these measurements and then we could adjust it for what the underlying, because we know what the curve is for resting metabolic rate. And once we'd adjusted it for the underlying circadian value in resting metabolic rate at that certain time, like knowing that breakfast was at 8 a.m., lunch was at 1 p.m., and dinner was at 6 p.m. So we know what the time is, looking at the corresponding time, looking at the corresponding RMR value based on that previous research. There was literally no difference in the thermic effect of feeding in response to these meals. So the reason for all of this is because RMR is itself a circadian rhythm. So if you see variation, then that typically means that underlying factors haven't been accounted for, as long as like the same meal is being fed to people or the same energy content of the meal. And total daily energy expenditure is obviously a byproduct of multiple factors in terms of actual exogenous energy intake, the energy expenditure, then as a result of individual body composition, thermic effective feeding, resting metabolic rate, and physical activity thermogenesis. So the three major ones are RMR, physical activity, and postprandial or thermic effective feeding. And those factors are themselves influenced by body composition, for example, RMR specifically. Those really are not, as far as like all of the emphasis was typically on the thermic effect of feeding, and then physical activity thermogenesis can be just really variable. But actually, RMR itself is the one that's of kind of most interest because it's the majority contribution to energy expenditure. That is a circadian rhythm. It will change if your body clock changes, but it's not going to shift in response to a difference in meal times or a manipulation of the energy distribution across the day or any of these factors that chrono-nutrition typically looks at. It's not going to shift because of meal frequency, for example, higher versus lower meal frequency. So yeah, a total daily energy expenditure is just not a factor that appears to be modifiable by any of these kind of chrono-nutrition interventions.
When you earlier you said that with fat loss, you may find that things might be a little bit slower. What do you think that would be? Would that be from like a hunger standpoint, or what do you think would be the thing that would potentially like slow that down for someone if they do have, again, not necessarily like a shift worker, but they do have maybe some of these small dysregulations in terms of their circadian rhythm?
So yeah, if it was a free living context, then appetite would be one, the probably the kind of real factor that I'd end up looking at because we do know that there is this kind of degree of appetite dysregulation that comes with like circadian disruption. We also know that then meal timing itself does have an impact on appetite regulation. So people who typically have more energy earlier in the day, although it doesn't affect energy expenditure, it certainly appears to affect appetite and lead to better appetite regulation over the course of the rest of the day. If someone was having, this is a pattern that we often see with like sleep curtailment. If someone's having a degree of impaired sleep, or they're sleeping poorly, or their sleep is really inconsistent, what often happens is caffeine in the morning, delay eating, and then prone to overeating later in the day. And so that would be the kind of behavioral stuff that is going on that can make it difficult and might be knocking someone out of whack a little bit in terms of if they were really pursuing a kind of fat loss goal or a body composition change as a goal, would typically be those kinds of downstream effects of a degree of sleep curtailment or sleep impairment.
Yeah, that makes a lot of sense. It ends up just being the way that people naturally will kind of function when that happens. And
Yeah.
food choices usually aren't the greatest at night either. I'm sure that you can't really measure that just through circadian rhythm type stuff there. What about age in your circadian rhythm? Does it become less like robust? And what would that even mean? Does that happen when we age? Does that play a factor in anything?
Yeah, less robust is probably not the term for it. So the most of our internal circadian rhythm, which we would express it by that term chronotype. The majority of our chronotype, which is essentially basically whether we are, the colloquial term would be like a morning lark or a night owl. So the vast majority of that chronotype is driven by genetics. There's no massive like single gene that influences your individual chronotype. It's the additive effect of like multiple little genes that add up together to influence whether someone naturally has a preference for staying up later in the biological night, sorry, the external night. Your internal chronotype is an expression of your internal clock. So your biological night. So you will have people who naturally have a preference for staying up later and sleeping later if they were left to their own devices. You have people that naturally would self-select for going to bed earlier in terms of clock time and waking earlier. Most people are actually not extreme at either end. There are frequency distribution estimates based on large population data. The vast majority of people are intermediate types or like slightly early and slightly late. The people who would be moderately early or moderately or extremely early, that's honestly just about 7% of the population. And then moderately late and extremely late is about 20% of the population. So more people like moderate to extreme late than they are early. A lot of that is because of modern light environments. So in research where people are like brought out and taken into more natural light environments or get more night exposure, each hour of external light exposure brings that kind of internal clock forward by about 30 minutes. But genetics is the biggest one that influences it, followed by different strength of these time cues. So light, for example. So someone, let's say you and me both have the same chronotype on paper or like physiologically. We generally both have the same, as a result of our chronotype, bedtime and wake time. If I live somewhere where I'm outdoors getting really bright light exposure for a lot of the day, and you're in northern Canada, those completely different environmental signals will influence our chronotype, and our chronotype would modify. It wouldn't mean that I would become if I was a late type, I wouldn't just become a morning type because I'm outdoors. The modification is within the chronotype that you have, but it would mean that our timing would be different as a result of those different strengths of exposures. And then age, to your point, age is the third factor. But we see distinct life stage differences in chronotype expression, which is really interesting. So adults aged between 21-ish to 30 generally have a later kind of sleep wake cycle on work days. And adolescents, this whole thing about like teenagers are lazy and sleep all the time, that's actually a genuine reflection of a phase delay in your chronotype that occurs during adolescence, and then it normalizes from about 21 onwards. So there's pretty substantial differences. On average, adolescents end up with a delay in sleep of about 3 hours. But then when you get into kind of over the age of 50, it tends to then shift the other way. And there's a kind of shift towards being an earlier chrono. And then within adulthood, from about 30 to 50 is when it's just pretty stable. There's a general kind of consistency with that kind of expression of chronotype. So the two big age differences, adolescents and then middle-aged to older adults, and they're in different directions of effect. Adolescents delay, and then older adults come forward.
So if I understand this correctly, as we get older, again, there's genetics involved in this, right? Everyone's going to have their genetics in terms of their chronotype with that. But from what it sounds like, it will shift earlier into the day as we age, right? It shifts towards that, whatever
Yeah.
that is for you. And it is where there could be some issues with that, and that most people tend to, again, with the modern environment, it's that mismatch then. And that's where maybe that can start to add up, or am I right track there?
No, it just depends. Like there's also part of the tricky aspects of this research is disentangling effects that are just circadian from environmental or behavioral effects. That's always what you're trying to do is distinguish circadian from behavioral. Like there are often, especially as people age, there can be like various other factors that then influence sleep quality. And so health related stuff isn't always just attributed to changes in circadian rhythms in especially like in older adults. It's often like other factors that can influence their sleep quality, and that then is something that kind of starts influencing health outcomes, so to speak.
Yeah, makes sense. Cool. Just to maybe put a bow on like the circadian rhythm in terms of meal timing and chrono-nutrition, what would you say are best practices, and what would you have people focus on as like the big rocks? Because I'd be curious to hear your thoughts on this too. For a while, it was like, hey, calories are the only thing that really matters, right? And again, we're talking body comp here. Calories are the only thing that matters. And then people brushed off meal timing as it really wasn't that big of a deal. So I'm just curious, where are we at in terms of the research and like meal timing and stuff like that from a chrono-nutrition standpoint?
So I think we're pretty concretely able to say that meal timing interventions, whether they focus on restricting the period of eating, like time restricted eating, or whether they focus on distribution of overall energy, like having lots of energy in the morning versus less in the evening, have little to no meaningful impact on weight loss or fat loss, at least in a controlled context. There's certainly, it seems, some people in free living interventions that will benefit more from an earlier distribution of energy, and that in the context of weight loss. And that likely reflects to the impact of that on appetite regulation. And then there are metabolic benefits to that. So, although when it comes to, say, weight loss, body composition, I'm generally relatively ambiguous as to whether any of these timing factors, in the mean, I would say it's not something someone necessarily has to worry about. But there is definitely a type of person for various reasons that does seem to respond well to thinking about. And the thing about the early time restricted eating studies is by default, their early distribution of energy studies. I'm not convinced that restricting the period of eating makes any sort of unique difference at all, metabolically or in terms of appetite or anything like that. But I do think distribution of energy seems to be pretty consistently something that shows up as a factor, that earlier energy intake, better appetite regulation across the day. In a free living context, if someone was trying to lose weight without counting calories or obsessing over calories, that is something that could really be useful to them as a strategy. That's really the top line where it stands now. So I'm certainly not convinced there's anything useful in much in the time restricted eating research that we could take out of that. I just don't think it's a useful intervention at all for any kind of outcome someone might be interested in, which is a big change. And I guess where I was probably in 2018 or 19. But I do think distribution of energy intake is something that for some people would be a really useful way to feel less hungry and get better appetite regulation, especially if they were actually following a degree of hypocaloric diet.
I think I saw too, and I think this was one of the research updates you had on your website at one point in time, was around like meal timing and how we tend, at least I think it was an observational study. I think it was. I don't know the exact study off the top of my head. I'm sure that would help you out. But basically, it was like looked at like people tend to be hungrier in the evening. They also eat more frequently in the evening. Is that just like a natural biological thing or physiological thing, or is that, you think, just the kind of environment that
No,
we're?
yeah, I think that's really environmental. You see all these like fluffy kind of theories of when we were caveman, we ate like this. I'm like, no one fucking knows anything about that. Like when we were caveman, I'm pretty sure we just ate when we got it.
Yeah,
Like,
I don't know.
I just don't. I also like physiologically, it doesn't make sense. Given everything we know about the way that circadian rhythms align to different parts of the daytime and nighttime, it makes no sense from an evolutionary point because evolution is about adaptation, right? It makes no sense that large meals at night or at 9 p.m. would, don't get me wrong, I'm not saying that people don't eat like big meals in the evening. We do. But that idea that there's some way, human way of eating, I've never really bought any of those. I think a lot of it is behavioral. I think people wake up in environments that we have where we have incredibly busy, most people have just very busy lives and they're up and at it, and they often don't maybe take time to prepare breakfast. What we know about the impact of the way that appetite operates in this way is that if people defer eating early, they basically end up, once they do start eating, they have more frequent meals in more rapid succession, and those meals tend to get bigger. So it's a surefire way for most people to overconsume energy. Here's an observation that I think is always really interesting. Binge eating disorder. No one binges in the morning. There's no binge eating in the morning. I've never heard of it. And my wife works, she's a psychotherapist doing a lot of work in eating disorders. No one binges in the morning. Like people binge at night. And factors coincide. One is there is a natural rhythm in subjective appetite that tends to peak in the evening. So if someone's under-eaten during the day and then they start eating later in the day, they're really predisposing themselves to overconsumption. Yeah, I think a lot of that is behavioral and environmental. And I've just had so much feedback over the years from people, and there's evidence for this in published literature, but I've had so much anecdotal people struggling with regulating energy intake or appetite that kind of front loading distribution made a big difference and makes a big difference to at least some people. And there's a whole different question of T phenotypes and stuff like that. I don't know that necessarily is something that we have that good a handle on yet, but I do think that there are people that will do far better overall in their appetite regulation by considering some of those factors. But yeah, I think that tendency to defer eating then distribute energy, a lot of energy later in the day, I think that's really a kind of behavioral and environmental characteristic rather than something innately clock driven, body clock driven, except for in people who are very late chronotypes. That does make sense. They would obviously naturally want to just be because they want to sleep later and they want all of their behaviors are later.
Look, a big meal before, what do you think? My understanding is that when we look at circadian rhythm, it would obviously be there's a little bit of an impaired glucose tolerance in the evening. There's obviously that can potentially impact sleep, but then even digestion as well too, right? Those are hitting a triple whammy there if you have this kind of big meal right before bed. Is there anything that you tell people there around that or?
Yeah, I mean, it really, you do see like a lot of it, like you'd see extended elevations in blood glucose through the night. You do see these kind of metabolic impairments. But then the question I tend to get is people are just like, what time is late? And this is where it always gets complicated because the time that matters isn't the clock time.
Yep.
The time that matters is your internal body clock time. So this is why there's been some really interesting analyses that have looked at distribution of energy intake relative to like body fat percentage in people. And if you just looked at the association between like their distribution of energy or their last calorie timing or any of these kind of energy intake variables and clock time, and you said, we'll say 9 p.m. and we'll look at this association, you often don't see anything. But if you have data on individuals' melatonin timing, so you know what their internal body clock timing, and you analyze the relationship with that, then you see associations with energy intake in closer proximity to an individual's melatonin onset and elevation is then associated with higher body fat percentage. That makes sense given what we know about once the melatonin's elevated, it's an internal signal that it's now the biological night. It's now nighttime. So your body goes from the feeding and active phase to the fasting and resting phase. And then suddenly a big meal comes in. So you have this like impaired glucose tolerance, impaired insulin sensitivity type of response. So a way to think about this then pragmatically is, again, people know what their body clock is. If you're someone who goes to bed at 9 p.m. or you're someone who goes to bed at midnight. And the way to conceive of this, I think, is if you're someone that goes to bed at 9 p.m., that's your natural, this is when you really have like sleep pressure and you want to go to bed. And you're probably someone who then wakes up at about 5 or 6, something like that. Then yeah, a big meal at 8:30 is probably not ideal timing internally for you. A kind of 7 p.m. meal might be better, or 6:30. If you're someone that naturally is like you're having that same kind of desire for bed and sleep at midnight, then it doesn't make sense that you also then are like, I have to have my last meal at 7 p.m. because your body clock's completely different. You might be fine eating at 9 p.m. or 10 p.m. It depends for really extreme kind of late types. So this is where we're at, and this is why there's a big kind of disconnect now between what we know about chrononutrition and meal timing and how we can translate this for people in a real world context, because it all comes back to an individual's internal timing, and we still really only have like research that scratch at the surface of the relationship between internal timing and external meal timing. But that's generally the way I think about it as a useful heuristic. Like, how do we translate this into something practical? I typically say, when do you go to bed? And then work forward 2 hours from that and try to have your like last substantive meal about 2 hours before you go to bed.
Yeah, no, it's a good point you bring up, right? Because people do think that it's all the same, but it is very dependent on that person's individual, like when they go to sleep, what that looks like, because the circadian rhythm is very specific to that person. I'm assuming too, probably a lot of it is generally to come back to the behavior side of things. Someone that maybe stays up a bit later, again, they may have those habits that maybe aren't in line with good, healthy overall habits. Potentially, that's probably not going to be the case for everyone, but I'm assuming that's where that does start to come in. So the behaviors end up really being the big thing there with that. And again, the individual circadian rhythm is really the most important versus being like, hey, don't eat after X amount of time.
Exactly.
There.
Yeah. Yeah. It's individual body clock is the main thing.
So I guess to wrap this up, what would you say? We've had this extended conversation on circadian rhythms. I think we've hinted a little bit at but what would be some signs that maybe someone, hey, I need to look into this a bit more. Maybe what are some things that they would notice in their day to day where it's like, hey, I need to place a little bit more emphasis on my circadian rhythm, hygiene, health, whatever you want to call it there.
I think people who are chronically tired,
Yeah,
people who sleep poorly, digestive like issues as well. Like a lot of this I think, these are generally things that if they're chronic are like a little bit of a signal to, yeah, maybe these are things that I could start to get in line, because it is a system based on anticipation and timing. And the knock-on effects are often obviously with sleep-related stuff, but also some gastrointestinal stuff as well. A big part of advice with IBS for clinical dietitians is often just trying to get consistent meal and snack timing not just across a day, but then between days, and have that degree of kind of regularity so that the system attunes to that. So they're the kind of things that, like, if people are just, yeah, like chronically tired or just fatigued or feel like they're just subjectively not sleeping well and thinking, I feel like I got 7 hours in bed last night, but like, why am I not feeling 100%, so to speak? They're all the kind of things that I think are useful indicators that, like, maybe things are a little out of whack and maybe there are steps that one could take to try and improve on some of these parameters, feel better generally.
Yeah, no, I like that. I think it's simple as, hey, you should just, if you feel tired, this is probably something you at least need to look into and see if you can dial it in.
Yeah.
I know, coming from someone that I didn't grow up with the greatest sleep habits, and I definitely, looking back, like I just thought I was a bad sleeper, but looking back at my old habits, man, this stuff really does make a big difference in terms of how you feel and everything like that. And even training, we have a 1 year old. And so it's like, I've had more days where I've had to train a little bit later in the day. And then even then I can see a difference in terms of my motivation to want to go train, how hard I can push myself in it. And then I think there's even have to be careful with intensity as well too, right? Because I do think that can also impact my circadian rhythm on the back end of, now I may not be as tired as I normally would at my normal time too. I really do think if you pay attention to this stuff, it really does start to make a difference there. And again, I can speak from experience on my own end with that.
Nice.
Cool, Alan. Is there anything that maybe we missed in terms of circadian rhythm stuff, or anything, I guess, that maybe even, I think a good thing would be, is there anything specific that you're really looking forward to seeing more information come out on, more research, or anything like that?
Oh, I'm looking forward to the study we just finished before Christmas. I'm looking forward to getting into the data for that and seeing whether, is it just breakfast time, is it just that morning meal, or is it the fasting duration from the night before that influences that? So I guess that's what I'm most excited for. That'll be towards the second half of this year, though, before I have any answers.
Research takes time, and it's a lot of work. It takes a long time. I always tell anyone who does research that comes on, it's, you guys do some work there, and it's insane because it takes forever. So
It takes a
you
long
have to be
time.
patient, and a lot of work too. Not only does it take time, but also a lot of work too.
Yeah.
Cool, Alan. Well, is there anywhere where you want to lead the audience to? Anything else coming out on your end that you want to let them know about, or anything like that?
No, not quite yet. If people are interested, my research review is Alinea Nutrition, so people can find me there. And for nutrition and healthcare professionals, I hope it's a good resource in terms of staying on top of research in nutrition. But that's the main place that people will find me, and the Sigma Nutrition podcast with Danny Lennon as well. So we're still cranking out some episodes there.
Yeah. Do you spend less time on social media than you have in the past?
Yeah, Instagram at the Nutritional Advocate. I'm actually, this year I had just been just not at all bothering with it the last kind of year or two, and I was busy, and then running the studies, it was just like the last thing on my mind. But this year maybe I'll get a bit more active. So maybe I'll be a bit more active this year.
Awesome, man. Find more. I don't think that's a bad thing that you're not spending as much time on there. You got to be careful.
No.
Yeah. And again, I can vouch for Alinea Nutrition, the research review. I'm in it, and I think it's freaking awesome. Ton of great information in there. So definitely go and check that out there. Even whether you're a coach or not, or anything like, I think even just everyone could benefit from it. Cool, Alan. We'll really appreciate your time. We'll have to get you back on again in the future, and we can obviously talk about your studies coming out and everything like that. So really appreciate your time, and we'll talk to you soon.